So you learned the basics of classes and interfaces. Over the next few videos, we're going to talk about the 4 core principles of object-oriented programming. It's easier to explain it using a real example. So in this project, I'm going to add a new class called account. This represents a bank account. Now here we need a field for storing the balance of this account. So public float balance. Now with this implementation, we can go to the main class and create a new account. Now, we have repeated the class name twice, so it's better to use the var keyword over here. Now, with this implementation, we can set the balance to any amount. We can set it to a positive value or a negative value. But what if negative balances are not allowed in our application? We shouldn't be able to write code like this. In other words, we shouldn't allow other classes like the main class to change the state of this object directly. They shouldn't be able to change the data in this object. So to solve this problem, we go back to our account class and replace this public keyword with private. Public and private are examples of access modifiers. Many other object-oriented languages have the same concept. Now, back in the main class, we have a compilation error because we cannot access the balance field from outside of this class. It's hidden inside this class. So within this class, we can use it anywhere, but we cannot access it from outside of this class. But what if we really need to change the balance? How are we going to be able to do that? Well, here in the account class, we can add a method, public void set balance. We give it a parameter called balance, and here we set this.balance to balance. Now, because we have a method here, in this method, we can perform some kind of validation. So before setting the balance, we can make sure it's a positive value. So if balance is greater than 0, then we can set it. Now, a better implementation is to throw an exception or an error if the balance is an invalid value. But let's not worry about that. We don't want to do too much Java in this course. We want to stick to the basics. This is what we call a setter, a method that is used for setting the value of a field. By the same token, we can have a getter. So if we want to read the value of the balance field, we can call a method called getBalance. So public float getBalance. And here we return the value of the balance field. This is the encapsulation principle in action. So encapsulation is really about bundling the data and methods that operate on the data within one unit or one class, and hiding the values or state of an object inside the class. So with this, we can create robust applications. We can prevent our objects from going in an invalid state. So this is the encapsulation principle. Now, we can take this to the next level. Instead of this method, setBalance, it would be better if we had methods like withdraw and deposit. So instead of setting the balance to some kind of random value, it's better to record some kind of transaction so we know when we deposited or withdrew money from this account. So let's add a new method, public void deposit. We give it a parameter called amount. And then we can set this.balance to this.balance plus amount. Or in Java, we can use the augmented assignment operator. So we can rewrite the statement like this. This.balance plus equals amount. These two statements are identical. Now in this case, we don't even need the this keyword because our parameter is called amount. So that is better. Of course, here we need to do some kind of validation as well. We want to make sure that amount is a positive value. So if amount is greater than 0, then we update the balance. Similarly, we're going to add a method called withdraw for taking money out of this account. Once again, we add our validation logic. If amount is greater than 0, then we reduce the balance by this amount. This is a better implementation. So let's get rid of the setBalance method. Now from the main method, instead of setting the balance to some random value, we can use the deposit or withdraw methods that we created. So initially, we deposit $10 into this account. Then we withdraw $5. Finally, we get the balance and print it. So SOUT tab, that's our print line statement. And here we can call account.getBalance. Let's run the program. And the balance is $5. Beautiful. So this is all about encapsulation. Next, we're going to talk about abstraction.